Welcome back. Today's video I have dedicated to my Gurudev, Sri Ramakrishna, because today is the birth tithi of my Gurudev. In my earlier video, I had discussed about uniform convergence of a sequence of function, and I had discussed the MN test of the sequence of function. Today I will discuss some question of MN test which had come in CSIR net exam. First question is which had come CSIR net December 2018 exam. The question is, for n greater than equal to 1, consider the sequence of functions. Here the sequence of function is look like fnx equal to 1 over 1 plus 2nx and gnx equal to x over 1 plus 2nx, and these two functions defined on the open interval 0, 1. Then consider the statement. First option, the sequence fn converges uniformly on the open interval 0, 1. The second option, the sequence gn converges uniformly on the open interval 0, 1. And option are look like, first option is true, option 1. Second option is false, and third option, first option is false and second option is true, and option 4, both first and second option are true. First sequence of function is 1 over 1 plus 2nx, and this is defined for x belongs to open interval 0, 1. Notice, limit n tends to infinity, obviously 1 over 1 plus 2nx tends to 0. That means, that implies fnx converges to the function fx equal to 0 pointwise. Okay? Now I will check, is this convergence is uniform? To check uniform convergency, I will apply the MN test. At first, just recall what is the MN test again. Fnx converges to fx for all x belongs to E, and consider Mn equal to supremum x belongs to E, absolute value of fnx minus fx. Then we can tell by Mn test Fn converges to F uniformly when Mn tends to 0 as n tends to infinity. Are you getting what is the Mn test for uniform convergency? Okay. And at first I will highly recommend you, if you don't see my earlier video about Mn test, at first see this video. Then today's video would be so easy. Here I will apply at first Mn test. Mn equal to supremum x belongs to E, means here the domain is open interval 0, 1, fnx minus fx. Just put the value, this is equal to supremum x belongs to open interval 0, 1, fnx means 1 over 1 plus 2nx minus 0, and this is equal to supremum x belongs to open interval 0, 1, 1 over 1 plus 2nx. Now we have to find the supremum value. Consider this function as gx. Gx equal to 1 over 1 plus 2nx. Then g prime x would be minus 2n over 1 plus 2nx whole square. And this value obviously less than 0 for all x belongs to open interval 0, 1. That means since g prime x less than 0 for all x belongs to open interval 0, 1, that means gx is decreasing function. Are you getting? And since gx is decreasing function, that means supremum exists only at the point 0. And at the point 0, this supremum value would be 1 over 1 plus 0. This is equal to 1. That means here mn tends to 1 as n tends to infinity. But to prove the sequence of function be uniform convergence, we have to prove mn tends to 0 as n tends to infinity. This will break the relation. Are you getting? Well. Next sequence of function is gnx equal to x over 1 plus 2nx. We can write this as 1 over x plus 2a. At first we have to check the pointwise convergence limit. Notice, obviously limit n tends to infinity, gnx equal to 1 over plus infinity. This is equal to 0. That means the sequence of function gnx converges pointwise to the function gx equal to 0. Now we have to check, is this convergence is uniform convergence? Here mn equal to supremum x belongs to open interval 0, 1 x over 1 plus 2nx. Consider this function as before again, gx equal to x over 1 plus 2nx. Then calculate the g prime x. This would be 2nx plus 1 minus 2nx over 1 plus 2nx whole square. Then this value equal to 1 over 1 plus 2nx whole square. Okay? Obviously this value greater than 0 for all x belongs to open interval 0, 1. Since g prime x is greater than 0 for all x belongs to open interval 0, 1, that means obviously the function gx is monotone increasing function on the set x belongs to open interval 0, 1. Are you getting? Since the function is monotone increasing function, that means supremum value exists at the point 1. And this value would be 1 over 1 plus 2n. Then if we apply the limit, then limit n tends to infinity 1 over 1 plus 2n. Obviously this value tends to 0 as n tends to infinity. That means here I have got the value mn tends to 0 as n tends to infinity. That means our given sequence converges uniformly to the function gx equal to 0. Are you getting? Now let's see option. First option is 1 is true, but I have got the first function is not uniform convergence. That means option 1 is wrong option. Also option 2 is wrong option. And option 3, 1 is false and 2 is true. This is the true option because I have got the given first sequence of function is not uniform convergence and second sequence of function be uniform convergence. And option 4, both 1 and 2 are true. This is also wrong option. That means Only one option here true. This is option 3. Are you getting? Similar type of question which had come CSIR NET June 2019 exam. The question is, let gnx equal to nx over 1 plus n square x square, which is defined for x belongs to close 0 open infinity. Then, which of the following statement is true? Option 1, Gn converges to 0 pointwise but not uniformly. Option 2, Gn converges to 0 uniformly. Option 3, Gn converges to x where for all x belongs to close 0 open infinity. And option 4, Gn converges to x over 1 plus x square where for all x belongs to close 0 open infinity. First I will check the pointwise convergence. Here x belongs to close 0 open infinity. This is the gnx. We can write it as easily. Then limit n tends to infinity, gnx equal to limit n tends to infinity x over n over 1 over n square plus x square. And obviously, if you put the limit, then this value would be 0. That means the sequence of function gn converges to the function 0 function pointwise. Now we have to check, is this convergence is uniform convergence? Let's see. To find the uniform convergency, I will apply the Mn test where Mn equal to supremum x belongs to close 0 open infinity, gnx absolute value of gnx minus gx. This is equal to supremum x belongs to close 0 open infinity, gnx just put the value, this would be nx over 1 plus n square x square minus 0. That means this value equal to supremum x belongs to close 0 open infinity, nx over 1 plus n square x square. That means we have to find the supremum value of this function in this interval. Consider this new function as a phi x equal to nx over 1 plus n square x square. Now, to find the supremum value, calculate at first the phi prime x. This would be 1 plus n square x square times n minus 2n cube x square over 1 plus n square x square whole square, which is similar to n times 1 minus n square x square over 1 plus n square x square whole square. This value is equal to n over 1 plus n square x square whole square times 1 plus nx times 1 minus nx. This value always greater than 0. This is also greater than 0. But notice here, this part 1 minus nx would be greater than 0 when nx greater than, here less than 1, and 1 minus nx would be less than 0 when nx greater than 1. Are you getting the meaning? That means for x less than 1 over n, this value greater than 0, and x greater than 1 over n, this value is less than 0. That means here the critical point at the point x equal to 1 over n. Because here vary at the point x equal to 1 over n. When x less than 1 over n, then the value is greater than 0, and when x greater than 1 over n, then the value is less than 0. That means the function has a maximum value 0.1 over n. Okay, now put the value. Now this supremum value would be n times 1 over n over 1 plus n square times 1 over n square. Then this value would be actually 1 over 2. Are we getting? Since mn converges to here, how? That means the function is not uniform convergent. Means our given sequence gnx converges pointwise to the function gx equal to 0. But this convergency is not uniform convergency. Okay? Well. Now let's see the option. Option 2 also right. Wrong option obviously. And obviously this true option also wrong. Only first option is right option. Gn converges to 0 pointwise but not uniformly. Okay? Now I will discuss another interesting example of such type which had come in CSIR NET June 2017 exam. The question is, for all n greater than equal to 1, let fnx equal to x e to the power minus nx whole square where x belongs to real number. Then the sequence fn is option 1 uniformly convergent on R, option 2 uniformly convergent only on compact subset of R, option 3 bounded and not uniformly convergent on the set R, option 4 a sequence of unbounded function. At first, I will say what is the sequence of bounded function. We all of us know a sequence of bounded function means fn is sequence of bounded function if each fn means f1, f2, f3 so on all be bounded. And bounded means we all of us know a function fn is bounded on the set R if there exists mn such that absolute value of fnx less than mn is true for all x belongs to R. Are you getting? Function is fnx equal to x e to the power minus nx square which is true for all x belongs to real number and n greater than equal to 1. We can write this as x over e to the power nx square. We all of us know growth of e to the power nx square always be greater than growth of x. So, since this growth is bigger than this part, so obviously this terms always less than 1 for all n greater than equal to 1. Okay? That means if we apply mod both sides, then this would be absolute value of fnx equal to absolute value of x e to the power nx square which is less than 1. And this is true for all x belongs to real number and for all n greater than equal to 1. That means for this relation, obviously the sequence fn is a bounded function. Okay, are you getting? Well, that means option 4 is a wrong option because option 4 indicate this sequence is sequence of unbounded function. So option 4 is wrong option. Now I will see option 1, option 2 and option 3. Option 1, 2 and 3 indicate about the uniform convergency. Option 1 only indicate uniform convergent on R and option 2 indicate uniformly convergent on compact subset of R. And option 3 indicate not uniformly convergent on R. The sequence is a bounded on R. So, to find the uniform convergence, we can apply MN test on the whole set R. So, we have to find supremum x belongs to R, fnx minus fxx, which is defined as Mn. We have to see Mn tends to 0 as n tends to infinity. And here supremum x belongs to R. Fnx means x e to the power minus nx square and fx means 0. That means we have to find supremum of this function in the whole real line. To find supremum of this function, consider this function as a Ax, which is equal to x e to the power minus nx square. Just recall, maximum of any function. To find the maximum of the function Ax, at first we have to check As prime x equal to 0. Suppose x not be the solution of this set, then if A is double prime x less than 0, then A's has a maximum. Now we have to find the A's prime x, which is equal to e to the power minus nx square minus 2nx square e to the power minus nx square. And to find the maximum, we have to check A's prime x equal to 0. That means this value would be e to the power minus nx square times 1 minus 2nx square, which is equal to 0. Since we all of us know this part is not equal to 0 always, that means from this line x equal to plus minus square root of 1 over 2n. And if you find A is double dash x, you will see at this point always A is double dash x less than 0 at x equal to 1 over square root of 2n. That means this function has a maximum value at the point x equal to 1 over square root of 2n. Now put the value, then this would be 1 over square root of 2n e to the power minus n times 1 over 2n. Then this value would be, just calculate, 1 over square root of 2n times e to the power minus half. As n tends to infinity, Ax obviously tends to 0 function. Means our proof has done. Mn tends to 0 as n tends to infinity. Okay? But this sequence of function is uniformly convergent on whole real line. That means option 1 is a right option. This is uniformly convergent on whole real number. And option 2 indicate uniformly convergent only on complex subset of real number. This is not true, because not only on. That means option 2 is a wrong option. And option 3 indicate bounded and not uniformly convergent on R. This is also wrong option. That means only option 1 is a right option. Are you getting? Well, here one thing noticeable, here I have applied Mn test in whole real number because the sequence of function is a bounded on whole real number. Okay? Well.